All right, so I think that should be working. Are we USB to? No, that's not. Let's try. That work better? Yeah. All right, that should work better. Hopefully, that wasn't the setting from before. All right. So, plan for today is to go over the very briefest, actually not even that brief, but a true introduction to dimensioning. Okay. And so dimensioning, when we're talking about drawing files, is the act of putting dimensions on the different views for the sake of communicating how big something is. And just a quick side note, these dimensions here are going to auto-populate with anything that you have, as long as you're doing it in Inventor. I have dug through all the settings and I can't figure out how to make those the actual numbers and lines bigger. I mean, it should be fine. You can always zoom in and see what it actually is. I'll be working on that, but regardless, the concepts are the same. So in a, is this it? In a part file, when you put a dimension on something, like let's say a rectangle, and you want to put on some dimensions, the act of putting the dimension on the sketch is very similar to putting the dimension on a drawing, in that you click on dimension tool, you click on the line you want to dimension, you move up a little bit, and you click to set it. Okay, same thing here. Dimension tool, click on the line, go over, click to set it. The difference is, in a drawing file, you are changing the size of something, or you're, locking it in place. But either way, you're putting something on there and you can then change it to change the size of something. That is a different principle than what you are doing in a drawing file. I'm going to do all this. In a drawing file, you're putting dimensions on there to communicate the size of something that already exists, or, digitally exists. Okay, so that is the point of all of, in fact, the entire point of drawing files in general is about communicating more about the object. Obviously, a picture is a very useful way of determining or communicating the size and shape of something. And this isometric view, this top right view that's shaded, does a lot for that. And the fact that we know this entire project is made out of 3/4 inch wooden cubes means that this is actually probably enough for someone to see and then recreate this. But we are always trying to, these are real simple exercises in learning these more complex concepts. And so we need these skills to be scalable. When we get to more complex things, the whole point is somebody should be able to look at a single, well, I suppose multiple drawing files, and be able to recreate the object exactly without any sort of description without you saying anything, or without any sort of paragraph, like this part goes to the, just these are essentially blueprints. Blueprints are technical drawings. These blueprints and the dimensions on them, along with multi-views or exploded views and assembly views and that sort of thing, that is about being able to tell somebody how to make this, how to build this, what you propose to build, that sort of thing, depending on the context of it, whether you are being paid to design something, or proposing something, or paying somebody else to build it. You've designed it, you want somebody else to build it or manufacture it. They would need to know the exact amount to do things, and that's the point. All right, so the majority of the conventions meaning like common practices and standards that we do in this class are sort of generalized. You know, the fact that the way I have you do multi-views are front, top, right, and then top right is the isometric. It's sort of arbitrary. If you do end up going in sort of drafting or architecture, engineering, something like that, whoever you work for or whatever professor you go to will have their own standards, and that's fine. Just you will understand the concepts, and the ability to follow directions is sort of the point. But the overall concepts of being able to communicate, that's the main point. But also, a lot of communication is making sure that obviously you have all the information you need, but not more than you need. Having more information than you need lead to confusion. For instance, all right, we know that, and this is just one of what I call the dimensioning sins, used, not euphemistically, what's the word I'm looking for? Sarcastically, okay? Sort of the rules of things to not do, because you're not always going to be, you can't always say, don't dimension, don't have your extension lines cross, but you can do your best to avoid that. But the point is about avoiding confusion by, most common one would be over dimensioning. So if you know that this is this view right here, this is the front view right there, and this is the right side view looking that way, this height of 2 blocks, it's the same no matter which side you put the dimension on. So you could, in theory, dimension this and see that the height of the entire thing is 1.5 inches, or you could put the dimension over here and show that the height is 1.5 inches. But having it in both places is wrong, because it's over dimensioning. You have dimensioned the height of this object twice, or I have, I suppose. It's not a huge critical error in that if you had both of those dimensions on there, somebody would be confused and it would break and it wouldn't work. They wouldn't understand how to make it. But if you start having everything on there twice, and these aren't even very complex designs, it would start to get a little crowded, and it's all to the good or to the bad. Does it make things better to have both of these dimensions on there? No. Okay. So we're going to go over the different strategies of how to go through this, and it actually is going to be a little confusing if you had the type of cube where you did the multiple block part files. Let's see here, because I don't know, it's just going to be a little more difficult to sort of see contours, which is a huge part of this. Contours meaning like the perimeter edge of the part or the shape. But let's just go through the other things. It should be all right. All right, so first, let's just go through these in order. Assembly view, for our sake, assembly view is just going to be sort of our cover sheet. Okay, it does work it is a useful document in that you could see how it all goes together. You could argue that the exploded view does a better job of showing how it all goes together. And I actually would like this to be a little bit of a lower. I'm going to switch to a custom view and make it look a little bit like this from what I had, if you recall. And that's a little better. Okay. Yeah. So you could argue that the exploded view works better to show how things go together. Just that's how, you know, the IKEA assembly required type of drawings do a good job, but it's going to work more like a cover sheet. And we are going to go ahead and title every one of our sheets. It will get much faster. So up on the toolbars, the tool tabs across the top, you can see that they are different than the ones that you get when you're looking at a part file. In the drawing file, place view is, remember, each drawing, I guess you would say, is a view. Okay, these are 4 different views. This is a front view. That's an F, not an R. Top right, and this is top right isometric, technically top front right. Whatever. Okay, so there are 4 different views. So place view means to choose what you're going to, and if you've made it this far, you've already got that, now that I think about it. Okay, annotate in general just means to like make notes. In technical drawings, it's any one of these sort of either dimensionings, part list, text box, that sort of thing. How the easiest way to do text box stuff is just to put a text element on top of it. There is a way to edit it as a sketch, but we'll just call it puzzle cube and see what happens. Saib CU puzzle cube assembly. And we could probably make that a little bigger. No. Let's highlight and like that. Yeah, that's not too bad. And I don't know, any sort of graphic application is going to have its own quirks about where you click to drag it and where you double click to activate it. And can you just edit it with the text tool activated, or you have to cancel the tool in order to edit the thing? I don't know, figure it out. Best teacher ever, figure it out. All right, and there you go, name. So we're going to need name and title on every document, every sheet. It'll take about 3 seconds after a little bit. Some of you will have stuff auto-populated depending on how your account's set up, but date gets auto-populated. That's nice, but you can see how, all right, so check this out. You can see this text is probably a little small from what I would like. We'll double click on it to edit it. If you just change the font size, which actually is in literal size, it won't do anything. You have to highlight the text you want to change and then change this. And I'm not terribly concerned with what goes where. I mean, this is not a bad, let's just go with this. Title of the sheet. Okay, puzzle cube assembly, puzzle cube exploded view, blue piece, something like that, in the box called title, and just put your name in the one above it. More important than having your name in this box, you know, instead of this box or whatever, is being consistent. Okay, don't put your name here and the title here in one, and then put the title here and your name over here in the other. Like, be consistent. Okay, it's better to be always wrong than occasionally wrong. I don't know, that's an oversimplification, but Be consistent. Consistent looks intentional. Let's make this a little bigger. How about 0.2? Well, if I want them to be the same on every time, I don't really need to make it a custom size. All right, so that's all you need for the assembly sheet. And let's save as you go. Let's call this 2021. There we go. If you ever see this, do you want to save changes to blah, 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 blah? Always do yes to all and okay. I'm not really sure the consequences if you don't, but that's what I've always done, and it's always been fine. Until it crashes my computer this time. Oh no, did I break it? No, there we go. Wow, that would have been awkward. All right, second sheet. A little bit more to do with our assembly view. Excuse me, exploded view. Let's just go ahead and put our text in there because that's what we're doing. Puzzle, cube, explosion, exploded view. And I was making my titles the 0.24. And let's fix this so that it doesn't wrap. There we go. And one for the name. Da, 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 da. And center it nice and pretty. There we go. All right, so for the annotations for your assembly views, you are going to have a parts list. So you're going to click on parts list, and this dialog box window will come up. It says select view. That means select the drawing, the view that you want to create a parts list for. We only have one view, so we'll click on that. And then OK. And yes, we do want a bill of materials. Hit OK. And you'll get a little box that you need to snap to a corner. Do not, depending on where you have room, bottom left is good, top right is good. I'll put it down here. And make sure it clicks. I mean, it just looks so sloppy if it's like that or over. It would never have anything go over the border. Oh my God, never. But it gives you a nice, easy click right there. Click to set it, hit OK, and you will see that the part names, I mean, these are from when I remade them, which is why they have a strange name, but it will auto-populate with the name of each of the parts in your exploded view, which there are 5. It will give them each an item number, which will make sense in a second. And let's see if we can get rid of the description box. Let's do right click, edit parts list. No, I think it's parts list style. How do you do edit? Yes, edit parts list style. And then column chooser, and we'll get rid of description, remove, hit OK. And then there's probably a save and close here. Then you actually have to remake it. Parts list, click on this, hit OK. And it will be like that. Okay, so I know there's a lot of complicated steps for those of you who are even paying attention right now, but it will be on the video. So that is something you can follow more technically there. Okay, so in addition to the parts list, we're going to throw on some balloons, which the balloons you'll see will auto-populate with the corresponding number that it goes with. So you're going to get a balloon. Just click on the top part. You don't have to click on the drop down. And click on the edge of the part that you want to start the balloon to, and then double click to set it. Again, all these annotations are super small. Okay, and okay, so you see it auto-populated with a 4, and if you look down here, item number 4 is the orange piece. So you need one of these for each. Think about, we don't want super short lines. Okay, that's not the idea, but we also don't want crazy zigzag, that sort of thing. Just something reasonable. And so it's one click to start it from whatever point you want to start it. So somewhere on the edge in this case, and then double click to set it. Okay, and you just need one for each one. Not very hard. Boop-a-doop-a-doop. All right, and yeah, so that's it for that. All right, so fortunately, that's the easy stuff. Not unfortunately. It just is. It just is the easy stuff. Okay, so for the multi-views, that is where we need to get into our actual dimensioning rules. And I need to get you some of these documents. Okay, that is called dimensioning standards. What is the other one called? Dimensioning guidelines. All right. Let's put it. Let's put those in the drive so that yeah, there we go. That's a place to put them. And let's go new Google Docs. And let's call this one dimensioning. Weird. All right. And this one should be here. Let's get rid of this. All right, so I'm going to attach or link or share these documents in the whatever this thing is called, our class spreadsheet, so that you can see where I'm getting the information from. And let's see if that's there now. Wow, that's weird. Then how did I get it there before? Docs. Okay, I think it is this one. All right, so it's going to be in our docs situation. And so this also has the green sheet stuff from before and inventor stuff, but let's talk about actual dimensioning. and let's do our best to stick with it. All right, so like I said before, it's all about communicating the size and shape of something and also avoiding confusion. So all the rules are about making sure that you fully, completely communicate what something, how to build something. Okay, for instance, well, all of these coming through here are, I can't believe how much Google Docs makes PowerPoint just sort of dissolve. Why can't, like, Google definitely has the ability to make PowerPoints import without messing up spacing. They're doing that on purpose. Oh well. Okay. All right. So these are not necessarily in order of worst to best, but they are all relevant. Okay, so we've seen the multi-view before. We know that, so the width of this object, the distance from the left side to the right side, regardless of where you put the dimension, you can see here is 2 inches. And you could have the dimension here on the top view or on the front view, but given the option, you'd rather have it go to the view that gives more information about the shape itself. Okay, we are going to do these dimensionings for the green sheet shapes that you already have done, and it's going to make a little more sense when you have more complex objects to do this through. And I sort of played with the idea of doing this on those first and then coming back to this. And there's benefits for both, but we're just going to do the learn dimensioning on the puzzle cube. Regardless, you would want dimensions to go where you can see what they're actually dimensioning, where on the top view here, these dimensions, and I'll show you the bad one here right above it. Well, first of all, this first issue that they're actually talking about isn't just about contours, it's about duplicated dimensions. Okay, over dimensioning is a sign that you don't know what you're doing. It's also, as parts get more and more complex, the more lines you have on the paper, the more likely a confusion could take place. And it's all about keeping things neat and clean to avoid such a confusion. So you don't need to duplicate dimensions, obviously not on the same view, but also this 1/2 inch height, it's the same thing. You only need one of them for sure. Then you sort of go down the hierarchy of which one you would want. Okay, regardless, no over dimensioning. Number 2, unnecessary dimensions are another form of over dimensioning. If you know that the entire width here is 2, the distance from the left side to this first notch is 3/4, and the distance across the top is 3/4, you can figure out that the remainder is 0.5. It has to be. It's 2 minus 0.75 minus 0.75. Having that is over dimensioning. Same thing here. Having this extra one here, you know that this first notch is 0.5. The whole thing is 1. You don't need this other one. And a lot of these, like how to avoid this type of thing, are, what's going on? Are steps for doing these things. It won't be hard to avoid because it will like just sort of you'll see the process that we do it will make it easy to avoid these problems. Okay, again, no unnecessary dimensions. That's over dimensioning 2. Okay, dimensioning. So we know we don't want the dimensions in both places. Okay, we don't want over dimensioning. Now the question is where to put the dimensions. And we want to put them on the view, meaning which one of these 3 views. We want to put it on the view that gives the most information about what the contour, what the dimension is actually dimensioning to. And that's why you'd want to put the dimensions where it shows what is happening. Okay. You can't, from the top view, you can't tell if this is like a sloped face or a curved face or anything. All you can tell is that something happens 3/4 of an inch from the side, something else happens 1.5 inches from the side. But if you put those dimensions on this front view, in this particular case, you can see what's actually happening at those distances. That adds information. That's what we're looking for. Okay. And a good tip is that your front view should be your main view. It should be the direction that gives the most information by itself. And therefore, most of your dimensions are going to be on the front view. Again, not always, but generally speaking. Okay, dimension to the contour. 4, whenever possible, don't dimension to hidden lines. Your puzzle cube parts are not going to have a ton of hidden lines. They won't have any hidden lines if you did the block view. If you did the this way, I don't think there would ever be a hidden line. But let's see if I find one that does have it. Okay, so a hidden line is one of these dashed lines, and that is because there's an edge sort of back here. Give me a second, come on, pen tool, I clicked on you. Oh, okay, we're good. There's an edge back here. That's what this represents. There's no edge on the front face, but the edge where this face turns into that face is hidden, but there is a line, there's an edge there. And so you would draw, if you were actually hand drawing everything, a dashed hidden line. The computer takes care of it for you. Like I said, if you're doing the block view, you won't have any hidden lines because of the way the edges work. But when we all get to the green sheet parts, there will be hidden lines. And the goal is that you don't put dimensions to hidden lines when possible. There's going to be hidden lines some of the time if there's interior edges for more complex things. But a lot of the stuff for today is just about introducing these concepts, and so we can refer back to them later. Okay, so major issues are things, anytime you have lines cross, you want to do whatever you can to avoid it. And that's why when we keep referring to it, or when we refer to it later, the dimensioning standards or hierarchy of dimensioning sins. Okay, you don't want any of your dimensioning on top of or inside of the view, or crossing extension lines, which are essentially the same issue of having lines cross. Means that, oh, it's not on here, it's on this one. Having lines cross, again, major possibility for confusion, miscommunication. You want to keep your view as clear as possible, the actual part. It's not always possible when you have holes and interior edges, but we'll do our best. Okay, so try to keep your dimension lines and the dimension lines technically are these, just this part right here. Or those are, excuse me, extension lines, dimension arrows. Don't worry about the details. But we're trying to keep our views clear as much as possible. You never, like this is barely even a rule because there's no reason to ever do it. Have extension lines touch or connect to other views. No reason for that. Let's fly through the rest of these. Okay. So you've seen so far, all of the dimensions have generally been in this space or in this space, like on the sheet. Where does it actually go? And you do your best to keep the dimensions, like the width dimensions should go here and the height dimensions should go here as opposed to outside. The reason for that is when, let's say you have your width dimension here on the front view, if you want to see some detail, you're looking at some detail on the top view, you only have to look this far away to see it as opposed to on the other side. And like as you travel down the view, it seems a little ridiculous, but the further you have to look down this sheet, again, the slight increase in possibility of miscommunication is there, which is why we put our dimensions sort of in the area in between. Plus, it sort of looks better as sort of keeping everything tidy. Again, an important thing. We do not want extension lines to cross, even though all of these extension lines are outside of the actual part. We don't want the extension lines to cross, and that's a reason why you would put it on a different view. Like you'd put the height, instead of having the height and width dimensions on this view, you'd put the height on the right side view. Again, extension lines going across the view. Circles and arcs are dimensioned where they look like circles and arcs. But we'll get to circles and stuff later when we get to the green sheet parts. All right, so the general rule, this is now we get to actual useful stuff, is we're going to start on the left side, or rather, if you chose a good front view, your front view is going to be where most of your stuff happens. And the first thing we're going to do is we are going to do, first we're going to do stacked dimensions instead of chained dimensions. So stacked dimensions are going to look like this, where everything is going to be dimensioned from one side, and I need to rearrange some things, give myself some more space. Let's get rid of the dimension tool. Range like that. So stack dimensions look like that. Everything is going to be from the left side. The alternative is chain dimension, which would look like this, and where they just sort of connect across, and that's fine. Like that tells the story, and it's to a view that it fits all our rules. It goes to the view that has the contour. It doesn't cross over anything. It's not over dimensioned. If you had a dimension, like if you had total width also, that would be over dimensioning. But just having this is not, but our standard is going to be stack dimensioning. And that is, we're going to start from the left side. Well, first, we're going to do width first. Okay, first width, then height, then depth. Okay, width is going to start on the left side and work right. Every time something happens, take a dimension. Okay. Folks, if you guys are just sort of fading out, now's a great time to pay attention because this is like the actual stuff that you're going to need to do. Okay, start on the left. Every time something happens, take a dimension. The first thing that happens is at 3/4 of an inch or 1 block in, makes a move in this direction. Okay, so we're going to do dimension tool. First click is on this corner here. Second click is either on this line or this point, either way, and make sure it goes up and click first dimension. Now we go back to the left side. The next thing that happens is where the notch goes back down. Okay, and then going back, the only other thing that happens is total width. That is total width, left to right. Every time something happens, take a dimension. Boom. Okay, now we do height, top to bottom. Going from the bottom up, the first thing that happens is this notch right here, or this first block high, and that's fine. It could go here on the front view or here on the right side view. Not both places, because it's redundant. Both places would be over dimensioning, but they both fit all the requirements. They both go to a contour. Neither of them crosses over a line or crosses over the view. If you only have one, it's not over dimensioning. So either one is fine. I tend to default to the front view just because, but it really doesn't matter in this case. Then, so we go back to the bottom. The only thing that happens else going height-wise is total height. Now, the problem is if I put it here, even though the stack dimension looks good, it crosses extension lines. So we need to put this height dimension somewhere else. Technically, we could also move the total width, but one of them has to go. And I'll just go ahead and put the total height here on the right side view and get rid of this one. And there we go. We did height. Every time something happens, take a dimension, top, bottom to top. You could, of course, do top to bottom every time something happens, but just stick with me and you'll be fine. I think aesthetically having more dimension, have the dimensions work building up tends to look a little tidier, but you can still meet all the rules by doing top to bottom. So the only other dimension is depth, which is front to back, which depth is either here on the top view going this way or on the right side view going that way. That is the depth dimension. And we're going to follow our same rules. Start at the front, and every time something happens, take a dimension. Working backwards, the first thing that happens is this, which is the same as this. This from the front back. I'm going to put it on the top view because we already have these extension lines here. And I do realize how these small extension lines are probably making it a little difficult to see, but we'll just have to power through. I'll see if I can fix those. And the only other depth dimension is total depth, which this total height here from before kind of gets in the way. So I'm just going to put another depth dimension here. And that is it for this blue part. Okay, so I just need a title. If it doesn't already populate, let's call this blue. We could just call it blue or blue.ipt or blue part or blue piece. But if you call this blue piece, don't call the other one green part. Be consistent. Blue part is fine. And another one for name. And I've been making these 1 1/8 big. And I've been centering them. So let's just center them so they look right. And there we go. That's a blue piece. Super easy. I'll do probably, most of you have something like this, either the true 5-piece L or the 4-piece L, which is this one. So this is super easy. This is only going to have 4 dimensions on the entire thing. Okay, starting width left to right. From the left edge of everything, the first thing that happens is this, where the contour goes down this way. And the question is, which of these two is better, top or front view? And it's definitely better on the front view, because even though these are dimensioning the same things, on the top view, it's just a line here. You can't tell what's going on, but on the front view, you can tell that it's a square turn that goes downward. And so we're going to keep the one from the front view. And then the only other width left to right is total width. So we can put that there, and there you go. Okay, so now height down to up. First thing that happens is this notch, and we can choose between these two, but the front view, the one on the front view is definitely better. Goes to a contour. And then the only other height dimension is total height, which could go here, but that's not good. We don't want that line crossing. So we'll put it over here on the right side view. And so these parts for Puzzle Cube, I keep saying because it's true, are very simple. So the trade-offs are going to be very obvious as to it's better to put the dimension here versus over there. When we get to more complex things, you are going to have to run down our hierarchy of issues as to, well, if my option is dimensioning to a hidden line versus having my extension lines go across the view, I would rather have my extension lines go across the view than have to go to the hidden line because it's less bad. That's not going to be, probably not going to be an issue for the Puzzle Cube, but we'll get to that. Then, okay, so we have width left to right. Every time something happens, take a dimension. And if you don't understand when I say every time something happens, it will make sense more so later. But it just means anytime there's a change. So something happens here, okay, and this turn here and this turn here, those are the same thing, or they're on top of each other. You can tell there's only one line there. And then the only other thing that happens is the edge of the entire piece. Okay, so that's left to right. Every time something happens, take a dimension. Then down to up. Every time something happens, take a dimension. And then width front to back. This only has one dimension width-wise, excuse me, depth-wise. And it is total depth, and it could go either place. But having both is wrong. Having both is over-dimensioning. And I'm just going to put it over here on the right side view because I already have another dimension on the right side view, although that's just completely arbitrary. And tidy things up, you like having one long dimension like that and another one like, I don't know, that sort of looks sloppy. I wouldn't ever take points off because, you know, you had it like this instead of like this. But, you know, be consistent, make it look nice and neat. So our method of working left to right every time something happens, take a dimension, will save you from a lot of mistakes, like having longer dimensions outside, excuse me, shorter dimensions outside longer dimensions. I mean, you should be able, not knowing anything about dimensioning, you should be able to tell that that's wrong. It just looks weird. It kind of hurts my brain to look at a little bit. And, you know, not just because extension lines are crossing, just think about what it would look like if you had a dozen width dimensions on there and some of the shorter ones were outside of the longer ones. It just doesn't make sense. And again, neat and tidy is part of it. Avoiding confusion, miscommunication, that sort of thing. And okay, so I'll do one on here. It's a little more difficult to use the phrase every time something happens because there's something happening every block if you did the multi-assembly situation. So you kind of have to look at it as if it was one of the single parts. And if you want to, you can remake it. It's not that hard to remake things. You've made much more difficult things than these part files. And you wouldn't need to remake the assembly or the exploded view. You could just make individual parts for this if you want, but if you don't want, that's also fine. But the difficulty here is realizing not just where something happens, but also making sure that when you actually use the dimension tool, and folks, a lot of you did these multi-assembly parts, which is fine. I think it looks pretty cool. But if you do not pay attention to where you're actually clicking, it's not going to work. Okay. So our first dimension here is the distance from the left side to where this next one happens. And so we need to click on the farthest left point, and then somewhere, either this edge or this edge, which is where the actual block starts and stops. If you click on that notch to that notch, not only will it have the wrong number, but it's not even dimensioning the right thing because you clicked on the top part of this chamfer. So make sure you think about these as entire blocks. A good tip or a bellwether sign that you've made a mistake is if any one of your dimensions is something other than a multiple of 0.75, you clicked somewhere wrong. Like if you get a 1.45, you didn't do it right, because every one of these dimensions should be a multiple of 0.75. And if you look closely at where you're clicking, it will be obvious. But this one, same thing, left to right, every time something happens, take a dimension. I don't think you could have more than 3 dimensions. Okay, so the word dimension is used at least 3 different ways, and not to be confusing with 3 dimensions. Dimension is obviously, we live in a world with 3 dimensions, height, width, and depth. Okay, that's one use of dimension. There is dimension as in the verb of putting dimensions on a view or putting dimensions on a sketch. Okay, so it's the verb of putting dimensions on there. And then it is also, of course, the dimensions, which meaning the dimension lines and their values. So I don't know, it's like we ran out of words or something, and we have to use the same words multiple times in the same context, but we'll just deal with it. So we need to dimension the dimensions in all 3 dimensions, and we'll do our best. So in the width dimension, we dimensioned every time something happened, and there are 3 width dimensions. Now height, from the base up, the first thing that happens is the height dimension. Now, this wasn't a conflict the first time we did this because of the way that, well, the way the lines work, because we want the dimension to this height here from all the way at the bottom, we're going to click somewhere on this edge, but then our extension line crosses over, which makes it a no-no, which means we need to put the first height dimension here instead of on the front view. So if you're doing the multi-assembly block situation, you do have a couple more hurdles, but it still shouldn't be that difficult. Then we still have total height and then total depth front to back. I'm just going to put it over here on the top view. There's the first one and the second one. And I clicked in the wrong place. You can see I clicked in the wrong place because of that. Haven't really thought about it this way before, but if you stick to width dimensions on the front view, height dimensions on the right side view, and depth dimensions on the top view, I mean, that's a way oversimplification, but in this case, at least, it definitely works. But it's really more about width, left to right, every time something happens, take a dimension. And as you're doing those, take a dimension every time something happens, you are working through the hierarchy of which is better or worse. And like I said, when we get to the green sheet, dimension those things, which we will do together, so don't sweat it. You'll get much better practice with that. Okay. So go ahead and do that. Just a quick reminder, assembly view on the front, title of the sheet, and name on every sheet. And when you save it, if you save it as something useful, it will automatically populate in the title box. So sheet 1 is your assembly view, 2 assemblies. I know I talked about this before, but the location of the view, you know, the individual drawing on the sheet tells you what angle of view it is. Okay, we know that this is the top view, this is the front view, and this is the right view. We also know that this view up here is the top right view because it's in the top right of the screen. This would be wrong because this is not the top right view. It's in the top right of the sheet, but it's actually the top front left view. But as long as you don't mess with it when you're doing the projected view, it's not going to be an issue. Because this is our front view right here, and if you saw the way I made it before, let's just get rid of this. When you're making the multi-view, your top right view, as long as you're starting from the front view as you're projected, will be right there. And you got to hit right click create. We talked about that before. There should be a video on the spreadsheet showing you how to do that. Almost positive there is. I'll double check. Okay, back to the front one. Okay, so we want 2 assembly views on our first sheet as sort of our cover page. But the key is that, so if we've chosen this as our first one, then, and let's look at, I think it's this one. So if this is, just happens to be our home one, I think I have 3-to-1. So if this is what I'm working with here, if I move it over, if I want to view here, it's got to be 1 notch to the right. Okay, because being to the right of this view means that it's to the right, its view is to the right of what we have. Not that difficult to tell just because of the colors of this, but still an important principle. You could work with a larger scale. 4-to-1 isn't terrible in this case. Of course, I need to fix the shading there. We'll go shade and 4-to-1. Let's fix this. Right click, edit view. Turn on solid or hidden line removed and shaded for these. 4-to-1 seems a good scale also, but you don't want it to barely fit in the space. And even though I'm pretty sure I could get a 5-to-1 to fit without crossing lines, you don't want it to be crowded. You want to use the space without crossing over lines or feeling crowded. And that's just an aesthetic thing. Okay, so that's the first sheet. Second sheet, assembly view with parts list. Remove the description box. If you missed that, it's in the video probably about 20 minutes ago. I don't know. And bubbles, 1 for each. Then a multi-view for each of the individual parts. Okay, left to right. Every time something happens, take a dimension. There's width. Height goes here in this case. Total height is going to be over here so it doesn't cross the extension line of the total width. And then depth. And there you go. I just did one of those. The scale is probably a little small. 4-to-1 might be too big. It should update the other ones also. Yeah, it does. So it updated the top view and right side view. Also text box and that sort of thing. And make sure you save it. Okay, I'm going to end the video there and let me know if you have any questions.